Hello and welcome back to Calculus2. We are continuing our section 7.5 on partial fraction decomposition. So yesterday we worked on these formulas that are used to set up partial fraction decomposition, looking at the denominator. And I forgot to tell you one of the major points, and that is that the degree in the numerator has to be smaller than the degree in denominator. If the numerator has the larger degree or equal degree as denominator, you have to use long division first, and then you will have the remainder to work on with partial fraction decomposition. So very interesting part. Now, we have two types of polynomials that we are looking at. We're looking at the binomial, which is the linear part, and the trinomial, which is the quadratic, which cannot be factored. And then we have repeated of each. You have to memorize these setup things. We can chain as many of these as we want. Clearly, for our calculation purposes, we don't want to chain more than 2 or 3 because that gives us 2 by 2 or 3 by 3 system. But then you have 4 by 4 system, 5 by 5, and so on. You can use matrix depending on how much math you know to solve these, and calculators can do some of the work for you as well. So for purposes of class and so on, I said that on exam I'll have one that it's either 2 or 3 variables for you to compute all the way. And then I'm going to have one with maybe 7 variables that is just going to say set it up. So let me take a look at those when I say set it up first, and then we're going to take a look at more of these examples, few more. So this problem says set up. So you have something like this. So we have a linear x minus or plus 0 squared. That's a repeated, right? So a over x plus b over x squared. Both of those color coding red, red. Plus the next one is again linear, repeated. So cx minus 1 plus d x minus 1 squared. Blue, blue. The last one is not repeated, but it's quadratic that you can't factor. So plus ex plus f divided by x squared plus 3. Purple, purple. 6 variables. That means 6 by 6 matrix. 6 equations, whatever. And that one will take really some time to solve, right? Because remember what you need to do. What's missing? Well, technically everything, so multiply, right? What's missing is to multiply, and so on. So this, solving this algebra, I don't know, 30 minutes? So a problem like this on the exam is you set it up and you walk away. It will say in the parentheses as well, do not solve. And it will give you this much of the room to work. So that should kick in the common sense that you're not supposed to solve. If you get the whole page for 2, 3 variables, right, and you get a quarter of the page for 6 variables, common sense should kick in at that point. If you are not reading directions. If you're reading directions, nothing to worry about. Always in life like that, right? The fine print. Oh, maybe I should put in a fine print. Get you trained to read that.
So the unsolvable quadratic will always have that form ex plus f.
Yes.
Numerator.
Yep, there it is. And then you can have a repeated one. So let's have one for you too. So set up. Yeah, the ugliest only I ever write. There we go. Integral there you go. Have fun. So what is the setup? What should I write? So I know that some of you had questions about these setups. Does this make sense? Now, this is the harder version of all the problems that we did earlier, right? We're not solving these because it's way too much. Let's see the easier case. So here we have problem 43 from the textbook. It says integral of x squared plus x plus 2 divided by x plus 1 times x squared plus 1 dx. Yes.
You like make them equal to 1, like make b equals 1 minus b as a substitute.
What do you mean?
Like basically when I try to solve it, I
Oh, that depends on which way you are solving. There are different methods, so that's why I'm going to get there, and then we'll see. We'll compare the notes. So the setup here, right, is a over x plus 1 plus bx plus c over x squared plus 1 dx. You see, these parentheses are not for decoration. We need them there because it's time dx. The next order of business is to solve this. So I have a times x squared, so ax. Why did this die? There we go. A times x squared plus 1 plus bx plus c times x plus 1. Which needs to be x squared plus x plus 2. So ax squared plus a plus bx squared plus bx plus cx plus c equals to x squared plus x plus 2. We have the red. We have the blue. And we have the green. So a plus b is 1. The blue equation says b plus c is 1. And the green is a plus c is 2. So now solve this system in any way you know, right? What I'm going to do is I'm going to copy the first equation, and I'm going to subtract these two equations. So equation 3 minus equation 2, so it's a minus b, is 1. Because a minus b, and then c minus c is gone, 2 minus 1 is 1. Now I'm going to add these two equations. 2a is equal to 2, so a is 1. If a is 1, b better be 0. And if b is 0, c is 1. You can solve these equations any way you know. I decided to eliminate c by subtracting 3 minus 2. You can solve this in any way you want. So when I subtract, copy the first equation. Second is a minus b. C minus c is gone. 2 minus 1 is 1. And then I see plus minus b. Add these, so 2a is 2. So a is 1. If a is 1, a is 1, b must be 0. And if b is 0, then c must be 1 to get 1. So that's the part on solving. And now we introduce our integral back. It was a over x plus 1 plus bx plus c, b is 0, so that dies, and c is 1, over x squared plus 2x plus 2. What now?
You want to do ln of x plus by 1 plus by ln of x squared plus by 2x plus by 2?
No. You have to use sub to get the ln on the second one. The first one is correct. The second one you cannot have 1 over x squared and get ln. That only works at 1 over x. Yeah.
Get the x squared plus 2x plus 2. That would just be the x squared plus 1.
Oh. Oh, I looked at the wrong problem. I was lazy to scroll. X squared plus 1. I was lazy to scroll up and look. I looked at the screen with the problem, and instead of looking at 43, I looked at 45. That's why. All right, so first integral, Kevin, you said it was?
ln x plus by 1.
And the second integral is? Well, 1 over 1 is 1, so. Yes. Look at the smiles on your faces when you solve the partial fraction decomposition. This one was under the handle simple irreducible quadratic factors. It starts with the simple, right? Probably vast majority of your friends would have heart attack just to see this. You get the Trump okay. We always have to work on a problem 66. I'm just going to change it from z's to x's so we don't have issues between z's and 2's. So we have 2x cubed plus x squared minus 6x plus 7 divided by x squared plus x minus 6 dx. Go.
You can find it online as you want to practice it at home. I'll do it here.
How's your long division going along?
Maybe professor, after you multiply, you're going to have
A part that you don't need to do, right?
got it. Yeah. And then the remainder.
The remainder goes divided by that. So the remainder will be the part to deal with the partial fraction, and whatever you divided is the simple integration.
Are you multiplying the two terms together? Are you adding? Are you subtracting? That's what I can't remember. With the remainder, you are dividing it by the x squared plus. No, I understand that. What I'm saying is with the part you can divide out, like this 2x minus 1, when you divide out this way, so that now what my minimum is 7x plus 1 over x squared plus 1 minus 6. Plus all together.
So long division first. Once you're done with the long division, partial fraction decomposition of the remainder, and you should find. I'll give you another 3 or 4 minutes.
You get minus x plus 6 plus 1. The remainder of minus x plus 6 is 1. That remains minus 2. Yeah, so it divides out.
All right, let's take a look at this problem. So long division. If you are shaky with long division, if you don't remember it or never learned it before, look up long division of polynomials on YouTube. About 100,000 videos on the topic. Should be able to get it. Now, to do the long division, we have x squared plus x minus 6 dividing into 2x cubed plus x squared minus 6x plus 7. So x squared goes into 2x cubed 2x times, and then we multiply back to get 2x cubed plus 2x squared minus 12x, and then we subtract. The first term dies. We get negative x squared plus 6x, and then plus 7. X squared goes into negative x squared negative 1 times. Multiply back. That's negative x squared, negative x plus 6. Subtract. First terms die. This becomes 7x plus 1. And now x squared doesn't go into 7x. So this is a remainder. So this integral is 2x minus 1 plus 7x plus 1 over x plus x minus 6 dx. So you see that the long division gave us this part here, which is easy to integrate, and this part here, which we have to use partial fractions for. So now we just go and we finish off the problem using partial fractions. 2x minus 1 plus this one factors over x plus 3, x minus 2. So I have a over x plus 3 plus b over x minus 2, everything dx. So we have to solve this. Cross multiply. Ax minus 2a plus bx plus 3b equal to 7x plus 1. So this is partial fractions now. A plus b 7, and negative 2a plus 3b is 1. Times 2 on the top and then add kills the a. 5b is equal to 15 because 7 times 2 is 14 plus 1 is 15. So b is 3. And if b is 3, a better be 4 because together they need to get 7. So now the integral that we have to solve is 2x minus 1 4 over, so plus 4 over x plus 3 plus 3 over x minus 2 dx. Integral of 2x is x squared minus x plus 4 ln of absolute value x plus 3. Don't forget absolute value. You need to have that. Plus 3 ln absolute value x minus 2 plus c. So this was one of the problems which featured the long division, and you have to be on the lookout for that. If the exponents on the numerator and denominator are the same, or the numerator has the larger exponent, you have to do long division first. If you have the larger exponent in denominator, you just go straight with the partial fraction decomposition. And that ends this section. That's it. So we'll take the break and then we'll go for the more.